Okay, so the type of things we've been talking about the last few days with these compound angles. We've been talking about problems like this. Oops. Where I apparently draw a really deformed box. And we're looking at that corner to corner there. But we're going to find angle R here and angle A right there. Now that angle A is a little different. We could also find angle T up here. And on top of all that, we're going to find this length. So I need to give you some dimensions. Let me give you this. We're going to go 0.6 inches, 1.4 inches, and 1.8 inches. To find angle R, what do we do?
Inverse tangent of the depth of the line.
You got inverse tangent of this dimension here would be the 1.4 over this dimension here, which is the 1.8. So second tangent 1.4 divided by 1.8. 37.87 degrees. So that is 37.87 degrees. Next, the length is probably the next easiest thing to find. The length is just going to be the square root of 0.6 squared plus 1.4 squared plus 1.8 squared. Which gives us 2.358 inches of length. So we've got the length. Once we got the length, then angle T and A are real easy to find. Angle T is just going to be the inverse cosine of this height here, the 0.6, over the length of cut, the 2.358. So second cosine 0.6 divided by 2.358. 75.26 degrees. Which means angle A is just going to be 14.74 degrees. Because those two have to add up to 90. Because it's a 90-degree angle there. Those two are the other two angles of a right triangle. Any questions on that? So the next stage, and that we did that in a couple different ways. We did that drilling holes. We did it kind of just generic like I just did here. The calculations are exactly the same. The next stage is what if we're not given any lengths except for the, not given any lengths, period. What if we're just told we're running a hole corner to corner there, and if I look at the projection from this side, it looks like this, and this angle is 34 degrees. Look at the projection from this side, looks like this, and this angle here is 18 degrees. Probably drew that way out of scale. Let me try that again. Something like that. This is 18 degrees. Well, we can pick a thickness or we can have a thickness given to us. I'm going to give you the thickness of 1.2 inches here. Normally we would do like 10 millimeters or something easy to use. I'm giving you the thickness here because I'm going to ask you to find, along with everything else, the length of the cut. And to know the length of the cut, you have to have the thickness of the material. To just find the angles, you don't need to know that thickness. So we're going to find angle R, the angle of rotation, and angle T up here, our angle of tilt. So we're going to use the 1.2 here to find this distance. This distance is going to be, if I call this X, it's going to be the tangent of 18 degrees equals X over 1.2. So we solve that, putting this over 1, cross multiplying and dividing. It is 1.2 times the tangent of 18 degrees, giving us 0.390 it looks like. So over here, finding that distance, if I call that Y, tangent of 34 degrees is going to equal Y over 1.2. Doing the same thing, putting that over 1 and cross multiplying and dividing, we get that Y is 1.2 times the tangent of 34 divided by 1, but we don't have to worry about that. We get 0.809. Now that we have those dimensions, and the fact that this is 1.2 inches thick, now we can find all the other stuff we've been asked for. R is just going to be the inverse tangent of 0.390 over 0.809. So second tangent, 0.390 divided by 0.809 gives us 25.74 degrees. I have to find the length next, which is going to be the square root of 1.2 squared plus 0.390 squared plus 0.809 squared. Which gives us 1.499 inches for the length of cut. So then T, our last thing to find, is the inverse cosine of 1.2 over 1.499. Second cosine 1.2 divided by 1.499. 36.82 degrees. What do you guys think? Not so bad? Any questions?
We figured out R.
Yep, R was right here. Inverse tangent of this distance over this distance is R. Okay, I'll give you your